Hello students. In this session, we'll be taking questions based from probability. Now students, after application of derivatives, probability is the next chapter which has most number of questions in this PDF. It has some good exciting questions, so let us get started. So students, the first question that we have is question number 13. Three fair dice are thrown. What is the probability of getting a total of 15 given that it's a case of conditional probability given that they exhibit three different numbers that are in arithmetic progression? Now here students, we're talking about three fair dice. So the outcomes will be 2, 1, 6. I hope you know this rule. It's 6 raised to n. So 6 cube is 2, 1, 6. So the outcomes are 1, 1, 1, 1, 1, 2, 1, 1, 3, and so on. Now we'll obviously not be listing on all the 2, 1, 6 outcomes. Now let us first understand the condition that is given. It is given that they exhibit different numbers that are in arithmetic progression. When we say different numbers which are in arithmetic progression, let us understand what are the different possibilities that we can have. So students, do you understand? The first possibility is that we can have 1, 2, 3. 1, 2, 3 is a triplet where the numbers are in arithmetic progression. This is an arithmetic progression with common difference 1. Let us now list down all the possible arithmetic progressions with common difference 1. So 1, 2, 3, we can have 2, 3, 4. We can have 3, 4, 5. We can have 4, 5, 6. And that's it. Now students, another possibility is if we reverse the outcomes, that is 3 to 1, then the common difference is -1, which is also an AP. So we'll have 3 to 1, we'll have 4, 3, 2, we will have 5, 4, 3, and we will have 6, 5, 4. Now let us list down all those outcomes where the common difference is 2. So if we start with 1, 3, 5, the next possibility is 2, 4, 6, and that's pretty much about it. If we reverse this, students, for negative common difference, we will get 5, 3, 1 and 6, 4, 2. Let's check, can we have triplets with common difference 3? So if we take 1, the next is 4, the next is 7, which is not possible. So these are the total possibilities. Now here students, total we have 12 outcomes out of, now here students, total we have 12 outcomes. Out of these 12 outcomes, we want those outcomes where the total is 15. So you have to just select those outcomes where the total is 15. So here, if you look at 4, 5, 6, the total is 15. 6, 5, 4, the total is 15. Do we have any other triplet where the total is 15? Well, not really. So it's 2 by 12. So 1 by 6 is the answer. Next, we'll move to question 14. In question 14, students, Rohit and Vishal, two below average students in a class, are attempting a math problem during revision classes. The respective probabilities of them solving it correctly is given 1 by 6 and 1 by 8. So probability that Rohit solves it correctly is 1 by 6. Probability that Rohit does not solve it correctly will be 5 by 6. Probability that Vishal solves it correctly is 1 by 8. Probability that Vishal does not solve it is 7 by 8. The previous experience shows that by solving the same question, the probability of a common mistake is 1 by 10. Probability of a common mistake, this is given 1 by 8. What is the probability that they obtain the same answer? Now, do you understand, students? The first possibility in this is, see, because they're getting the same answer, the first possibility is both are correct and they're getting the same answer. So both are correct means we are talking about probability of R into probability of V. Probability that Rohit is correct into probability that Virat is correct into probability that Vishal is correct. Plus, second possibility, both are incorrect. So when we say both are incorrect, so probability of R dash and probability of V dash. Now here you have to understand carefully, students, they are getting the same answer. If both are incorrect and they are getting the same answer, here we'll consider that they have made a common mistake and therefore we'll multiply it with probability of common mistake. So these are the two possibilities. The calculation is easy. P of R is 1 by 6 into P of V is 1 by 8 plus P of R dash is 5 by 6 into P of V dash is 7 by 8 into common mistake is 1 by 8. Do the calculation, students, you will get the correct answer. Let us proceed to the next question. The next question is question 23. So students, the next question that we have is, in an examination, a candidate takes 3 tests, namely alpha, beta, gamma, and the probability of him failing the first test alpha is half. So here, students, probability of alpha dash is given, it is half. Probability of alpha will also be half. The probability of passing each succeeding test is 1 by 2 or 1 by 4, according to whether he passed or fails in the preceding one. So if he passes in preceding one, then probability of him passing in the next one is equal to half, and probability of him failing will also be equal to half. But if he fails in preceding one, then the probability of him passing in the next one is 3 by 4. Sorry, it's 1 by 4, and probability of him failing will be 3 by 4. So now, students, further they are saying the candidate is selected if he passes at least 2 tests. What is the probability that the candidate is selected? So here, students, do you understand? There are different possibilities. First possibility is that he passes the alpha test, he passes the beta test, he fails the gamma test. So he's passing in two, so he's selected. Second possibility, he can fail the beta test. So he's failing the beta test and he's passing the other two. And the next possibility, he fails the alpha test, and then we have beta and gamma where he passes. Third possibility, students, he's passing all three. So it is alpha, beta, gamma. Once we have the students, once we have this information, let us now calculate all these probabilities and add them. For the first one, alpha, beta, gamma dash, he's passing the alpha test. So the probability of that is half. Into. For beta students, the preceding test is alpha. If he is passing in the first one, we are going to check this one. For beta, the probability of passing is also half. So that is. Now for gamma students, the preceding test is beta. He's passing the preceding one. So we'll again go to the same information. Here he's failing gamma. So probability of failing is still half. So it's again into half. Plus the next possibility students that we have is alpha, beta dash gamma. So he's passing the alpha test. That is half. Now for beta, alpha is the preceding one. He's passing the preceding one. In this case, the probability of failing of beta is half. So I'll write this as half. Now for gamma, the preceding one is beta students. When he's failing in the preceding one, we'll focus on this information. He's passing gamma. If he's passing gamma, that is going to be 1/4. Further students, we have probability of alpha dash beta gamma. So alpha dash over here students is failing in the first one. So that is going to be half. For beta students, the preceding one is alpha. Which means students, when he's failing, we're going to discuss about this. If he's failing in the preceding one, probability of him passing the beta test is 1/4. For gamma students, preceding is beta, he's passing that. So we'll go to the first information, probability of passing gamma is half. The last one students, he's passing alpha, that's half. For beta, he's passing the preceding one. So this is also half. For gamma, he's passing the preceding one. So this is also half. We can complete this easily, students. This is 1/8. Plus 1/16 plus 1/16 plus 1/8. I'll just make the denominators equal. This is 2/16. This is 2/16. So finally we have 6/16, which is 3/8. And that gives us the answer 3/8. Further students, we'll proceed to question 34. Question 34 students is super easy provided you remember what are independent events and the formula for that. They're saying event A and null event are always independent events. Let us check the formula. What is the formula for independent events? That P of A intersection B is equal to P of A into P of B. It is very easy to understand students that event A has some probability. But when we say null event, the probability is 0. So on the left hand side, see if it is a null event, there's nothing common between A and B, which means on the left hand side, probability of intersection is 0. And here it's P of A into P of B. We don't know what is P of A, but P of B is 0. 0 equal to 0. It just satisfies the formula, which means statement 1 is true. Next, they're saying sure event. So if we talk about an event A and another sure event S, is it equal to P of A into P of S? We have to figure that out. Now, students, what is the intersection of event A with the sure event S? Do you understand? Sure event basically means the sample space. So therefore, students, we can say that the intersection is event A. So left hand side is event A. For a sure event, the probability will be 1. So this is P of A into 1, which is again P of A. So it satisfies. Therefore, both the statements are true. Next, we'll move to question 38. In question 38, students, E1, E2 are two mutually exclusive events, which means their intersection, students, even intersection E2 is a null set, and therefore probability is 0. With a random experiment, and E is an event such that P of E is not 0. So now they are saying P. So here, students, see, you have to understand E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. Because P of E1 intersection E2 is 0, we can directly take this as P of E1 plus P of E2. So this formula becomes P of E1 upon E plus P of E2 upon E. We can do this simply because they are mutually exclusive and the intersection is the null set. So here, students, the assertion is true, the reason is true, and the reason is the correct explanation for the assertion. Next, students, question 57. It's a very simple question, a board level question. I expect you all to already know this. Rahul, a class 12 student, has a probability of getting a grade A in the examination of 3 subjects, math, physics, and chem. And these are the probabilities for grade A. Find the probability he gets a grade A in none of the subjects. Find the probability that he gets a grade A in none of the subjects. Yes, you are Rahul. So here, students, we have to find the probability of not getting a grade A in any subject. So that is going to be probability of not getting grade A in math. So that is 0.8 into 0.7 into 0.5. We're taking the complement and multiplying. That's it. You get the answer. You do the calculation and you'll get the answer. That's it. You multiply, you do the calculation and you'll get the answer. Next, students, question 58. A and B are two events such that P of A dash is given, P of B is given, A intersection B dash is given. You have to find B given that A union B dash has already taken place. Students, I personally prefer solving such questions with Venn diagram so that we have a clear idea of which set is given, which set is not given. So I'll be making a Venn diagram for this. If you remember the formulas, you can go ahead with that also. But learning too many formulas is anyways not easy. So I'll personally prefer this. So P of A dash is 0.3, P of B is 0.4. A intersection B dash, students. A intersection with B dash. Now B dash is this. So do you understand A intersection B dash is this part of A, which does not include the intersection of A and B. So therefore, this part is 0.5. P of A dash is 0.3 students, which means P of A is 0.7. If full A is 0.7, do you understand? The intersection so be 2. Further, students, P of B is given 0.4, which means this part of B is only 0.2 because 0.2 is taken away by intersection. Now, the formula for this is going to P of B intersection A union B complement upon P of A union B complement. Let's understand this region from the Venn diagram. B intersection A union of B complement. Let's start with B complement, students. So what is B complement? B complement is everything other than B. So do you understand? Region B complement is this region. When we say union with A, students, we'll have to include the intersection as well. And now you have to see the common part with B. Do you observe, students, the common part with B, this shaded region common with B is only the intersection, which means, students, that the numerator is 0.2. So from here we decide that this is 0.2. Upon P of A union B complement, as we already discussed, it's going to be B complement, it's full B complement, union with A. So it is everything other than 0.2, it is 0.8, and therefore, students, we get 0.2 upon 0.8, which is 2 upon 8, and that is 1 by 4. With that, we complete the sum. Let's proceed to the next one. The next question that we have, students, is there are 10 cookies in a box. 6 have chocolate centers and 4 have jam-filled centers. Shweta randomly chooses a cookie from the box and eats it. Then Ali randomly chooses and eats one of the remaining cookies. So we'll start with Shweta. Now they are saying what is the probability that Shweta and Ali choose cookies with different centers. Let's say, students, that Shweta chooses a cookie with a chocolate center. So the probability of that happening is equal to 6 by 10. Now from the remaining cookies, Ali is choosing a different cookie, which is a jam-filled cookie. So that is going to be 4 by 9 because it's remaining cookies. Now do you understand, students, we have discussed the case where Shweta is choosing a chocolate center cookie, but it's a possibility that in the next possibility, she chooses a jam-filled cookie. And therefore, students, will have to multiply this with 2. So here the answer is going to be, you cancel whatever is possible. This is 2 1s are, 2 5s are. That's pretty much it. Okay, 3 2s are, 3 3s are. So therefore, students, 8 by 15 is your answer. Next, students, will take question 60. In question 60, a biased dice is tossed with the respective probabilities for various faces to turn up. If an odd face has turned up, what is the probability that it is face 1 or face 3? So students, this is a case of conditional probability. Over here, we are saying that an odd face has turned up. Now, what is the probability of odd faces? So probability of odd faces over here will be probability of 1 plus 3 plus 5. So that is 0.1 plus 0.18. Sorry, it's 0.19 plus 0.15. So this is as good as 10 plus 19 plus 15, which is 44. So 0.44. What is the probability that it is phase 1 or phase 3? The probability for phase 1 or phase 3 is, students, phase 1 is 0.10, phase 3, students, is 0.19. So this is 0.29. So the answer, students, is going to be 0.29 upon 0.44, which is 29 by 44. Students, will take the next question, which is question 108. In question 108, they're saying that a pot contains 5 red and 2 green balls. At random, a ball is drawn from this pot. If a drawn ball is green, then you put a red ball in the pot. If a drawn ball is red, you put a green ball in the pot. While drawn ball is not replaced in the pot. Now we draw another ball randomly. What is the probability that the second ball is a red ball? So in the first case, that is the first ball, when the first ball is drawn, there are 2 possibilities. For the first ball being drawn, it will either be red or green. So if a drawn ball is green or red, what is the probability of the first one being a red? So that is 5 by 7, and this is 2 by 7. If the first ball is red, then in the second case, a green ball is put in the pot. So over here, do you understand? Now, if a red ball is drawn, one red ball is less, and that ball is not replaced. So that red ball is gone. So now we have 4 red balls. Initially, there were 2 green balls, but now we will have 3 green balls because 1 green ball is placed in the pot. Further, students, for the green ball, do you understand? When the green ball is taken out, here in the second case in the pot, when this green ball is taken out, now green ball is lesser. So we have only 1 green ball and a red ball is put in the pot. So then we have 6 red balls. So for the second case, this is the new situation in the pot. Now from here, students, we want the probability that the second ball is a red ball. What is the probability of a red ball from here? So that is 4 by 7. Probability of red ball from here is 6 by 7. So the final answer is going to be 5 by 7 into 4 by 7 plus 2 by 7 into 6 by 7, which is 20 plus 12 upon 49. The answer is 32 by 49. So students, in the first subpart, we want to find the conditional probability of obtaining a sum greater than 9, given that the black die resulted in a 5. Now let's take this given that condition. When we say black die resulted in a 5, over here black die is the second die. So students, we are talking about black dice being resulting in a 5, which means 1 5, second die is a 5, 2 5, 3 5, 4 5, 5 5, and 6 5. These are the 6 outcomes that we have. Further, students, out of these outcomes, we want those outcomes where the sum is greater than 9. When we say sum is greater than 9, you have to count those outcomes where it is greater than 9. So 5, 5 and 6, 5 has sum 10 and 11. So that will be my options. So it's 2 out of 6, which is 1 by 3. Further, second part, find the conditional probability that sum is not 4. Given that the numbers are different. When we say numbers are different, students, do you understand it's everything other than 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. If it's everything other than that, we are talking about 30 outcomes. Total is 30. Out of those 30 outcomes, you want those outcomes where sum is not 4. It's easy to calculate those outcomes where sum is 4. So that is going to be 1, 3 and 3, 1. Many students will make a mistake of considering 2, 2. Will not do that because the 30 outcomes do not have 2, 2. So there are 2 outcomes, 1, 3 and 3, 1 where sum is 4. So there are 28 other outcomes where it is not 4. So it's 28 by 30, which is 14 by 15. With that, we complete this question. Let's move to the next one. So students will take the next question, question number 122. In a Kabaddi league, 2 matches are being played between Jaipur and Delhi. It is assumed that the outcomes of the games are independent. The probability of Jaipur winning, drawing, and losing against Delhi are given. Now, students have to understand probability that Jaipur wins is same as probability that Delhi loses. So here, let me quickly note these details down. So probability that Jaipur wins is equal to probability that Delhi loses, and that is 1 by 2. Probability that Jaipur draws the game is same as probability that Delhi draws the game, and that is 3 by 10. Probability that Jaipur loses the game means Delhi wins the game, and that is equal to 1 by 5. This is the information that we have. Each team gets 5 points for win, 3 points for draw, and 0 point for loss in a game. After 2 games, find the probability that Jaipur has more points than Delhi, and Jaipur and Delhi have equal points. So let us do one thing, students. Let us first note down all the different possibilities for their points. What are the different possibilities that we have? So the first possibility is that Jaipur wins both the games. If Jaipur wins both the games, they get 5 for each, which means they get 10. And if Jaipur wins both, Delhi loses both. So they get a 0. All right. Second possibility, Jaipur wins 1 game and Delhi draws 1 game. So what is the possibility that Jaipur wins 1 game? So when 1 game is won by Jaipur, that is 5. And the second is a draw. So that will be 8. Now here, because there's a draw, then Delhi will get 3 points for that draw. So therefore, it's 8 and 3. Second possibility, students, both are draws. What if both are draws? So then both get 3 and 3 each for both the games. So it is 6 and 6. Second possibility, students, that Delhi wins 1 game and 1 is a draw. If Delhi wins 1, 5 for that and draw. So that is 8, and Jaipur, because it's a draw, it's 3. Another possibility, Delhi wins both the games and Jaipur loses both the games. These are the different possibilities that we have. Now, in the first case, do you understand? When we say Jaipur has more points than Delhi, if Jaipur has more points than Delhi, we are considering X being greater than Y. So if you want to, I'll just note this down over here. Jaipur is this and Delhi is this. So we're talking about the first 2 cases, students. Now, in the first case, 10 and 0, when will we have 10 and 0? When Jaipur wins both the games. If Jaipur is winning both the games, students, the probability of Jaipur winning is 1 by 2. So probability Jaipur wins first game is 1 by 2. Probability Jaipur wins second game is 1 by 2. Plus, second possibility, students, is that Jaipur wins 1, draws 1. So here, if Jaipur wins 1, the probability of Jaipur winning 1 is half. Probability of Jaipur drawing 1. Now, probability of Jaipur drawing is this probability of JD, which is 3 by 10. So that is 3 by 10. But do you understand, students, the sequence matters. It is a possibility that Jaipur wins first, draws second, or vice versa, draws the first, wins second, and hence into 2. This, students, will give you the answer for the first case that this, students, will give you the answer for the first part. So we'll quickly run through this. This is going to be 1 by 4 plus 3 by 10. You take LCM of 4 and 10, it's 20. It's 5 plus 6 upon 20. And the answer to this is 11 by 20. Would that we complete the first part? Let's move to the second part. In the second part, students, Jaipur and Delhi have equal points. Now, equal points is possible only in this case, 6 and 6. So students, when we say that they have equal points, that is 6 and 6. Now, do you understand both the games are drawn? So if both the games are drawn, then the probability that Jaipur draws the game is equal to 3 by 10. So this is 3 by 10 into second game is also a draw. So that is also 3 by 10. So students, they'll have equal points after 2 games. This is the only possibility, 6, 6. So the probability is 3 by 10 into 3 by 10, which is 9 by 100. So students will take the next question, which is question number 126. Question 126. In a raffle draw, 1000 raffle tickets are sold for rupees 1 each. Each has an equal chance of winning. First prize is rupees 300, second prize is rupees 200, and third is rupees 100. Let X denote the net gain. That word is important. Net gain from the purchase of one ticket. So students, let us prepare a probability distribution table. Once you get the table, the remaining part is super easy. Over here, students, there are different possibilities. The first possibility is that I take one ticket and I win the first prize. Second is I get the second prize. Third possibility, I get the third prize. Fourth is I don't get the prize at all. Now, in the case where I'm buying the ticket for 1 rupee and I get the first prize, in that case, students, do you understand that I'll get rupees 300? I invested rupee 1, I get 300. So my net gain is 299. Further, students, for the second prize, I'm investing 1 rupee. If I get the second prize, I get 200 rupees. So therefore, that is 199. If the third prize is rupees 100, I get the third prize. That will make the net gain 99. If I don't win the prize at all, so that, students, means it is minus 1. I've invested 1, it's gone. So the value of X, the net gain, is 1 rupee. So 1 rupee loss, basically. Now, what is the probability of us getting the first prize? There's only one first prize, so that is 1 out of 1,000. 199 is again 1 out of 1,000. Third prize is also 1 out of 1,000. What is the probability of being a loser? So that is 997 upon 1,000. Once you get this table, students, the remaining part is easy. I'm sure you know how to go ahead with finding the expected value and all. So you finish this off. And that leaves us with one last question of probability. That's question 127. In question 127, again, students, I'll tell you how to form the table. Once you get the table, then it's super easy. You can finish it off. So students, 127, Ram and Sham play a game with a coin. Ram stakes rupee 1 and throws the coin 4 times. It's a case of 4 points. If he throws 4 heads, he gets his stake and rupee 3. Let's do one thing. Let us first quickly note down what is happening here. If he gets 4 heads, see, he is investing 1 rupee. He gets his stake back. Plus he gets 3 rupees. So what is the net gain in this case? So that is rupee 3. His earnings is rupee 3. Further, if he throws only 3 heads, now when we say 3 heads, students, it will be H, H, T, and they are consecutive, they are saying. So it will either be H, H, T or T, H, H. In this case, students, he gets rupees 2. So that is again 2 and 2. If he throws only 2 heads and they are also consecutive, so H, H, T, T, H, cut, H, H, T, 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 H, H, and T, H, H, T. These are the 3 possibilities. In that case, he gets rupee 1. In all the other cases, Sham takes the stake money. Is this game fair? So here, students, do you understand? The values of X are 1, 2, and 3. The probabilities are going to be, X is 1. Basically, the money that he gets is to be 1. And that is, students, 3 out of 16, because the total outcomes is 16 because there are 4 points. So 2 raised to 4 is 16. In this case, students, for 2, it is 2 out of 16. In case of 3 students, it is 1 out of 16. What you have to understand is, students, in all the other outcomes, in all the other 10 outcomes, he's not getting any money. The money which is staking, that is 1 rupee, is gone. So therefore, minus 1 will be 10 by 16. So students, now you have to find the expected value. They're asking, is this game fair? If the expected value is 0, then it is fair. Otherwise, it is. So you can complete the calculation, students. I'm sure you'll get it. With that, students, we complete probability questions. We're done with this session. I'll see you in the next session for section C. Thank you.